in order to understand VLSM, you need to understand FLSM first. Okay, so before you start with the VLSM, make sure that you have watched FLSM. VLSM is variable length subnet mask. That will be mostly used, but it is a little bit complex. So what is it? VLSM is a subnetting techniques that allows a network to be divided. Look at here, that allows a network to be divided into subnets of different sizes. So that's the key. So you have one network and you will be dividing the subnet. You'll be dividing the network into multiple networks, but of different sizes based on the number of hosts required. Based on the number of hosts required. So in one case, maybe you need 8 hosts. In another case, you need 50 hosts. So based on the number of hosts, you are going to divide the network. Instead of giving every subnet the same number of IP address, VLSM allows the network administrator to allocate large subnets to networks that may host and smaller subnets to networks that need fewer hosts. Okay, networks that need many hosts and smaller subnets. So you can have large subnets to a network that need many hosts, and you can also accommodate like a fewer hosts in a small subnet. So your subnets will be of different sizes. This helps use IP address more efficiently and reduce wastage. Okay. Now, if you go to the FLSM, just imagine in case of FLSM, if you have different variations of the requirement, then FLSM is not efficient because you get the same block of IP address for each subnet. Now let's have a look at the difference between FLSM and VLSM. Okay, all subnets have the same subnet mask. So if it is /24, everyone will have /24. In VLSM, subnets can have different subnet masks. It can have /24, it can have /25, it can have /26. Okay, in the same network. Not in the same network, like in the same organization. Each subnet has equal number of hosts. So when you have the same CIDR value, that means you have the equal number of hosts. And when you have different CIDR values, that means you will have different sizes and you will have different number of hosts. Inefficient because many addresses may be unused, many usable IP addresses may be unused. Efficient because addresses are allocated based on need. So it is efficient because it will be based on needs. Less flexible because everything is fixed. Okay, more flexible. You got a subnet, you can again break it into smaller subnets. Again, you can break it into smaller subnets. Simpler to design, easy to do. It's a little bit complex. So for example, if you divide /24, like if you want to divide /24, you can make it four equal subnets with /26. And a /24 network divided into 25, 26, 26 subnets based on the host requirements. Now, let's begin with this one. Okay, so if you look at here very carefully, okay, if you look at here, let's say this is /24. Now, if you divide, like if you want to divide this into half, it will become like if you do /25, then you get 2. So this is /25, this is also /25. Now this is /26. Now look at here. When you get to /26, /25 will be divided into halves. Okay, /26 each of them is /26. Now when you again make /26 /27, it gets divided into halves. /27 /27 /27. So all of them gets divided as /27 respectively, all of them. Like in /28, again it gets divided into half, and /29. Okay, now if you look at here very carefully, when it was /24, I'm just saying the total number of IP address. I'm not saying about the usable IP addresses. That means this includes both the network address and the broadcast address. Okay, so if you look at here, when it was /24, it was 0 to 255. All the numbers were in the same place, like in the same room, okay, or you can say in the same pool. When it was /25, what did happen? The room got divided into halves. So if you look at here, so when we divide it into halves, it will be like, because the number of addresses, like all the numbers are the same, you cannot increase, so you cannot go below 0, like -1, -2, or you cannot go above 25. So when you divide it into halves, you get 0 to 127, then 128 to 255. This is for when you make it /25. When you make it, this is also /25, this is also /25. Now when you divide /25 again, when you make it /26, it gets divided into halves. So again, it gets divided into halves. So previously you had 0 to 127. Now it will be 0 to 64, 63, 64 to 127. If you see, the numbers are the same. There are 64 numbers, 64 numbers, 64, 64. Okay. Now, if you look at here, you got, like for example, 4 equal rooms with equal number of IP addresses, or 4 subnets with equal number of IP addresses. So this can be an example of FLSM, okay? Like you are using 4 of them, okay? But however, like the VLSM is beyond FLSM, okay? Now, if you can also divide this, and if you look at here, I actually ran out of spaces to write them properly. So I wrote, this is it starts with 128 and it ends in 143. It starts with 144, ends with 159. Starts with 160, ends with 175, okay? Again, if you do, this is /29. Again, if you do /30, it will get divided more, like it is going more and more, okay? Now, look at here very carefully. Let us take this one. So if you come here, let us take this one. So if it was /24, you had 256 total IP addresses, but usable IP addresses was 254. Why? Because you need to subtract 2. One is the network address, another is the broadcast address. When it was /26, you had 62 usable IP addresses. When it is /27, you have 30 usable IP addresses. When it is /28, you have 14 usable IP addresses. Now, if you look at here very carefully, this is /28. So if you look at here, we have 0 to 15. That means total 16 IP addresses, 14 is usable. Then 16 to 31, then 32. So if you look at here, you have 14 usable IP addresses. Now, what we're gonna do here is, okay, so I have this table and I have this one, okay? Let me take a requirements. Now, if you look at here very carefully, I have given 3 requirements. What are the 3 requirements that I have given? There is IT department, there is accounting department, and there is marketing department. IT department has 8 people, 50 people, 60 people. So what is that? I need 60 IP addresses for marketing department. I need 50 IP addresses for the accounting department, and I need 8 IP addresses for the IT department. Now, if I come here, so if you let me write down the requirements, 8. So if you remember, for let me have a look at it again. So IT8, accounting 50, marketing 60. IT8, accounting 50, marketing is 60. Now look at here very carefully. If I need 8 IP addresses, so if you look at here, here I have 6 usable IP addresses. If it is /29, then I have 6 usable IP addresses. So it doesn't solve my problem. But if I take /28, okay, /28, then it solves my problem. Okay, it solves my problem. Okay, now look at here very carefully. So I can take one from /28 because it produces. So let me take just this one for the, I will take this one for the IT department. Now for accounting department, I need 50 IP addresses. Here I have only 14 usable IP address. 50, no, it cannot solve the problem for 50. Here 30, it cannot solve as well. So the one that can solve the problem I can see nearest is 62, which is like you need something which is greater than or equals to 50. Okay, so that has solved the problem. So I can take, what is the value? It's /26. So I can take 1 from /26. Okay, let me just take 1 from /26. Okay, now I will take this portion, not this one, because I want to show you something. Okay, now then we have another one, marketing is 60. So I know that this 60 can solve the problem. So let me take this portion for marketing. Okay, so this is for IT, this is for accounting, this is for marketing. Now, is this right? How can you understand this is right or wrong? Okay, but I can see like it fits. Okay, like what's the difference between FLSM and VLSM? So if I had to take FLSM, for example, I needed at least 3 networks. With FLSM, I needed at least 3 networks. So let me do the FLSM here with green color. Okay, for FLSM, I needed at least 3 networks. Do I have 3 networks here? No, I have here 3 networks. Okay, so I have here 3 networks. I have 4 networks. So I can take this. According to FLSM, all the networks will have to be of same size. Okay, so all of them are of same size. Okay, and you have 62 usable IP address. So if you come here, it's /26, you have 62. Now look at here. If I bring the IT department here, for IT department, I need 8 IP addresses. But how many IP addresses I have? I have 62. What will be the wastage? So if you see here, almost 70% IP addresses are wasted. Okay, so this is not efficient. Yeah, it is good, it works, but this is not efficient. Okay, so that is why this is more efficient for IT department. So FLSM is not going to work here. Now let's come here. Why? Let's see. Okay, you remember this block? Let's come here. If you come to this block here, just take the IP address. So it will be, let's say we take a class C IP address. Okay, 192.168. So it will be, this is the network address and this is the broadcast address. So for accounting department, 192.168 dot, because we are doing /24, 25, 26, it has, we do it let's say class C. Okay, we can do it class B, we can do it class A as well, doesn't matter. 192.168 dot 0 dot, let's say the first one is, sorry, I forgot here, 128, and last one, there is a mistake here. Okay, there is a mistake. So it cannot be 190. Okay, so it will not be 190 here. So So if we look at here, if it is /26, let us look at the table for /26. For /26, it will be 191, it will be 191, and it will be 192. It will be 192. Okay, that was a mistake here. So it will be 191, it will be 191, and it will be 192. Okay, the formula is the broadcast address will be always an odd number. Okay, if you see the broadcast address is an even number, that means there is a mistake somewhere. Okay, the broadcast address has always to be an odd number. So this is 191, this is 192. Okay. Okay. Based on this, if I just write here 192.168 dot just 128 to 191, 128 and 192.168.0 dot 191. Okay. For marketing department, it is 192.168.0 dot 192 to 192.168.0 dot 255. Okay, now come for the IT department. See what we have here: 1, 2, 3, 4, number 5. Okay, 1, 2, 3, 4, number 5. If I see that, so 192.168.0 dot 176, 176. 192.168.0 191. Okay, now look at here very carefully. What's the problem? The problem is this accounting department and marketing department, they have overlapping IP addresses. They have overlapping IP addresses. Okay, because this is the one that you can only get if you divide these, if you divide this field. Okay, if you divide this field, only then you can produce this one. But you have already used this field, so how can you divide? If you are using a room, you cannot divide it. If you already have a house, you cannot build another house on the plot. If you have an empty plot, then you can divide it and you can build. You can divide it into 2 halves and you can build 2 houses. So you have already used this field, so you cannot divide it anymore. If you have to divide something, you need to divide something which you haven't used it. Okay, so this cannot happen. Now the question is, you might say, isn't it /26? Yeah, this is /26. This is also /26, and this is /28. It doesn't matter, because you get /28 by dividing from /26. So you already use /26. So you cannot divide it anymore. Okay. So you cannot use this part of the /26. However, this part of the /26 is empty. This part of the /26 is empty. So you can easily use them. So it is easy, but it is not that easy as well. Okay. You need to understand. Okay. It is also complex. So what we can do here is actually, let's remove this part here and let's take this one. Sorry. Or let's take this one. Okay. So if I take that one, then it will be 192.168.0.0 and 192.168.0. I think it will be 15 here. It will be 15. I think this is the one that we are taking. Yeah, it will be 15. 15, then /28. Okay. Now, if you look, is there any overlaps? There is no overlaps. Okay. Now your question could be, we still have wastage. Where we have wastage, for example, we have here 62 IP addresses, but accounting department needs only 50 IP address. There will be a little bit of wastage, okay? And in fact, if you think practically, that is also not wastage. The reason is, what if 1 or 2 people joins accounting department in 1 or 2 months? What if 10 people joins in 5 years? Okay, so you don't have to redesign the subnet again. So it's not an it's yeah, apparently it is an wastage, but overall, okay, if you think overall, that is what we can go, okay. But it is better than using, let's say for example, if I use this one, I will have 254, right? Now if I come here for the same thing, so if you look at here, for the same thing, if I come here, you see here for the accounting for the IT department, for the accounting department, I used 192.168.50.0/24. So this is your network address 50.0, and this is your broadcast address 50.255. So what's happening? You are having 254 usable IP addresses. That means you are wasting more than 200 IP addresses. It is better than that. Okay. So this is like a FLSM. Okay. This is like FLSM, you can say. Okay. But this is the one that we did here is the true VLSM. Now the question is, can we take anything from here? Of course you can take any field, but if you take it sequentially, then it looks more good, okay, and it is highly likely you'll not make a mistake. But if you pick the fields randomly from here and there, then highly likely, as I said, there could be overlapping IP addresses and you could get into trouble. Okay, so this is an easy VLSM. Okay, this is an easy VLSM. They are different networks. They cannot communicate with each other. Okay, even though if you look at here, they look the same, like 192.168.0, 192.168, but they are in different networks. Why they are in different networks? Because if you look at the subnet mask, even the subnet masks are same here, but they are still the different networks. Okay, if you do a little bit of practice, you will understand. Based on the subnet mask, their IP addresses got changed and they are in different networks. And here the subnet mask is different. As soon as I see the subnet mask is different, I know that straight away this is in a different network. Now, if you okay, this table is fixed. Okay, now I think it's not easy to memorize this one, but it's easy. I memorized, so it's easy. It's not that hard. The only problem is during the exam, you will be given with a lot of numbers. Let's say you'll be given with 7 or 8. Okay, and we are seeing something here like which is less than 250 or something, which we can solve with class C. However, you will be given a department with 500 IP addresses, a department with 1000 IP addresses, which cannot be solved with class C, okay? And it will get harder. So therefore, we should have something. Is there a way we can do it? The best way, the more you practice, the more faster it will become, and you will get used to it. Okay, this is the illustration I used only for understanding, but this is not practical. This is not feasible to do during the exam, drawing and writing those things. So you need to have some mathematical calculations and formula to do this one. Okay, let's say we want to solve this one. Okay, this is the one that we have been given, and I have some formulas here. What are the formulas? When someone gives you something, let's say someone has given you, okay, like for example here we got here 8, 50, 60, okay, so they will give you randomly. The first thing is, when solving a VLSM problem, the first step is to list all the required subnets from the largest number of hosts to the smallest. So you take the requirements and you arrange them from the largest to the smallest. Okay, this order is important because larger network requires more addresses and they must be allocated first to avoid wasting address. Now if you come here and if you look at here, if you started taking, like if you already take the accounting and the marketing from /26, you know that you cannot take this field for IT. Why? Because you know that you have already taken this, so these things are already dead. So these things are already dead because this part is already gone, okay? But had you started with IT from here, okay, for example, okay, then you started accounting, now you need to remove the IT from here. It would create a mess, okay? So never start with the smallest one, always start with the largest one. Now, start allocating from the largest requirements. So always try to solve the problem with from the largest host requirements, okay? Like for example, 120, 50, and gradually move towards the smallest. Now look at here, you need to follow the sequence, okay? That means you need to go sequentially. You cannot just pick randomly from here and there. Like I do this one, then I do this one. No, it doesn't work, okay? Use IP address, efficient IP address space, okay? Always check that one, make it efficient. Then no overlapping between the subnets. No overlapping between the subnets. This is very important. You cannot overlap between the subnets. Smaller networks can fit into the remaining address space, okay? You cannot have overlaps, okay? The one I showed you in the first place where we had an overlap with the IT departments and with the accounting departments. You cannot have overlaps because every device has to be identified with an unique IP address. Now, identify the appropriate class of network address. Now, when you got the requirements, for example, if someone says, I need 500 hosts, with class C, the max usable host you can get is 254. So you cannot get 500 with class C. So that is why you need to use class B. So make sure that when you select the class in the first place, you select the appropriate one. This is only possible if you start with the highest number, okay? If you start with the highest number, okay? Because without the highest number, it's not going to happen, okay? So I think you can write here highest number, okay? Whatever. Now, for class B, it comes like this, default, okay? Now, after selecting the network address, move the CIDR value to the right. Now look at here very carefully. We know /24 is the CIDR, /25 is the CIDR, /16, these are the CIDR. You can move the CIDR value to the right. So if you start with class B, so let's say this is the default that you have for class B. And for 500 hosts, how many IP addresses do you need? For 500 hosts, how many IP addresses do you need? Now look at here very carefully. If I do 2 to the power 8, I will get, if I do 2 to the power 9, then I will get 512 IP addresses. And if I subtract 2, then I will get 510 usable IP address. Usable IP address. Okay? Addresses, whatever. What is this 2 to the power 9? Is the number of host bits. Is the number of host bits. So I need only 9 host bits. So if you take this one, how many host bits do you have here? Okay? You have here total 32 bits minus 16 network bits. You have 16 host bits. But how many host bits do I need? I need only 9. So I can donate, or you can say borrow, okay, 7 to the network bits. Only if you give 7 to the network bits, then you will have 9, and the CIDR 16 plus 7 you will find is /23. Okay, so what is going to happen? The /16 will become /23. Okay, because I don't need this. I have total 16 host bits. I don't need 16 host bits. I need only 9 host bits. So what I need to do? I will give away 7 host bits to the network bits. Okay, and in this way my CIDR, my network bits will increase from 16 to /23 because 16 plus 7 is 23. Okay, now look at here very carefully. You might have to watch this part again and again. because this is a little bit complex. Determine how many bits are borrowed and create a subnet table. So if you look at here, the new subnet is /23. So we are borrowing 7 bits from the host bits. 7 bits can create a subnet combination. So with the 7 bits, you can create 1, 2, 3, 4, 5, 6, 7. You don't have 8 bits. So you have 1, 2, 3, 4, 5, 6, 7. Just 7 bits, okay? With the 7 bits, you can create 2 to the power 7, which is 128 combination, okay? So you can create 128 subnets. And each of them is unique, okay? So the binary values represents the possible subnet numbers created by borrowing bits. Each combination responds to a different subnet, which is within the original network. So you have divided. So previously you had a big network. Now you have divided this network into 128 networks. Okay. Like for example, if you look at here, we had a big one and we divided into 2. Okay. So if you have /16, it was a big one, and when you do /23, so you have one big network with /16, and when you did /23, actually we get 128 networks. Okay, you will get 128 networks, and these 128 networks can be used for example 128 departments. Okay, now let us come here and let us see what we have here. So if you look at here, let's say we took 192.168.1.0, okay, and we need, for example, we'll start with the highest number. So if we start with the highest number, then how many, what will be the one? We have 60, 50, and 8. So we'll start with 60. So how many host bits do you need for 60? So if you do 2 to the power 6 minus 2, you will see you get, if it is 2 to the power 6, it is 64, and minus 2 is you have 62 IP addresses. Okay, so if you look at here, so I need only 6 host bits. So if I take this number, so I took 192. So first of all, 192.168.1.0/24. How many host bits I have here? There are 8 host bits. But how many host bits do I need? 192.168.1.0. I'll make it /26 because I need only 6 host bits. Is that clear? I need only 6 host bits. So when we are making from 8 host bits to 6 host bits, we will borrow 2 host bits and we will give it to the network bits. And if we give it to the network bits, it will be /26. When you give it to the network bits, when you give 2 host bits to the network bits, if you look here, what happened? 2 bits, you can create 8 combinations. You can create 128 combinations. So with 7 bits, you can create 128 combinations. So with 2 bits, you can create 0, 0, 0, 1, 1, 0, 1, 1. 4 combinations. The formula is 2 to the power number of bits. Okay, so 4 combinations. You can create 4 combinations. So if you look at here, I'm creating these 4 combinations. When I'm doing from /24 to /26, I get these 4 combinations. This is table 1. Let's say this is table 1. There are 4 subnets. And each of them can give you 62 usable IP. Now, take the first one from the table. From table 1, first one from table 1. Take the first one from table 1. Then what you see here, according to the, what is the network address and what is the broadcast address? According to the formula, network address, all host bits zeros, and according to the broadcast address, all host bits ones. Sorry, make all host bits 0 and make all host bits 1s. So if you look at here 192.168 1 dot, these two bits are there, you cannot change it, okay, because when you are donating, when you are borrowing these 2 bits, it becomes fixed, okay. So you are taking the first one, from the table, leave the 3 in the table. So when you are taking, it is /26, so you cannot touch the network portion, so it will be again 192.168.1.00. Now make all the host bits zeros, make all the host bits on. So if you look at here, if you add, this is the network address and this is the broadcast address, okay. So this will solve the problem for 60 IPs. Now allocate subnet based on the host requirements. So according to here, you have got, according to table 1, you have got 4 subnets, each of them 64. Just take one subnets and put it for a particular department. Okay, do not modify bits that have already been allocated. Okay, once you allocate a subnet from a table, the borrowed subnet bits must remain fixed, so you cannot modify it. So if you look at here, this is the network portion for /23. This was the original network portion. These are the subnet bits that I borrowed, and they become the part of the network portion, and you cannot change them. Okay, if I'm making from /16 to /23, you cannot change them. The only portion you can change is the host portion. This is the only portion that is flexible. You can only change here. Now, according to this formula, okay, if you come here again, so I use the first one from the table and I cannot use it anymore because this is done. This is already used for a department. We can take the second one from the table. So the first one is already done with the 60 people. We'll take the second one from the table, so which is 01. So if you look at here, 192.168.01, 1.01. What is the formula again for the second one? Wait. I made a mistake. Sorry. Let's have a look. Okay, this is the second one. Sorry, this is the second one. Okay, I went here. Forget about this part. So this is the second one. Take the second one. Again, look at here. The first one from the table is this one. The second one is 192.168.1.01. This is the second part. So let's do here 192.168.1.01. So once you borrow the bits, you cannot change them anymore. Okay, you cannot change them anymore. You cannot modify them anymore. You need to leave them as it is. The network address and the broadcast address. So if you look at here, if you add those 128 plus 64 plus 32, if you add them, you will get 64 is the network address, and you will get here is 127 is the broadcast address. And look at here how beautiful it is. For the first one, the network address is 0 to 63. That means all the IP addresses are between 0 to 63. For the second one, all the IP addresses from 64 to 127. So you used the second subnet from the table. So if you look at here, the second one is also done. Okay, now you are left with 2 of them, and take one of them from here. Okay, I will take this one, the third one from the table. Let's take the third one from the table, 192.168.1.10. Now the issue with the third one is I required here 60, I required here 50, okay, but I required here 8. But how many IP addresses do I have here is 62. Why? Because it is /26. I saw the opportunity. If you come to the table here, if you look at here, if I make it /28, I will have 14 IP addresses. Okay, 14 usable IP addresses. So why don't I take it /28? Isn't it that is what is the VLSM? So we will make here /26. So if I draw here the table, you already have 192.168.1.10, which is /26. Rest of them is there. Now I'm writing this one into decimal format and I'm writing this into binary format. This is because of understanding. Otherwise it will take a lot of space for me, okay? A lot of space for me. Now, if I do here 192.168.1.10, and if I again want to borrow 2 bits, then it will be 00. I will have to create another table, 192.168.1.1001, 192.168.1. then 10, 192.168.1.11, then 11. So again, I divided this one into four parts, okay? Now it will become /28. It will become /28. Now take one from this table. Take one from this table, okay? So if I take the first one from the table, so if you look at here, these are the part of the subnet bits. That means I gave it to the network and I cannot change it. So you keep this one fixed, 192.168.1.1000, and according to the network address, all host bits zeros. According to the broadcast address, all host bits 1. So it is 128 to 143. So previously we had from 64 to 127. Now if you look at here, that is for 50 hosts. Now you have 128 to 143. It is obviously it is /28. It was /26. However, there is no overlapping. There is no overlapping. So you can use this one, a recap, okay? Arrange them in descending order, okay? Always start with the largest one, like the highest number, okay, or largest host requirements, and move gradually to the smallest requirements. Identify which class is required, and that should be done based on the first problem that you start solving, based on the first subnet that you want to solve the problem, okay, based on the first requirements. And you will always be using class B if you are using that one. Number 4, the CIDR value can move to the right only, so you cannot move it to the left, okay? So you can borrow bits from the host portions only, and your CIDR will move from left to right. Now when you are moving, okay, when you are moving from left to right, okay, you will be creating subnets with the number of borrowed bits. Each of them is a subnet, and you should write them, okay? Like if you borrow 7 bits, so it creates 128. You don't need 128 networks, you know that, but you know that you create 128 subnets, and each subnet is unique, and they can be used for solving each of the problems, okay? So if you took one, assign one subnet to the assign one subnet for each host requirements, then take the next available subnet, okay, then take the next available subnet. Like this subnet, if you see, it can be broken into other subnets as well. Let's say you took a subnet with /26 and it can be broken into 4 other subnets with /28. Yes, you can break that subnet, okay? Like for example, if you look at here in this diagram, we took these 2 subnets, and after that we broke again these subnets here. Again we broke it here in order to get our requirements. But the one that you used, you cannot break it. The one that you have used, you cannot break it. And the borrowed subnet bits must, once you borrow the subnets, okay, like for example, if you look at here, you create here 128 subnets, and this portion become fixed. These portions become fixed. You cannot change it anymore, okay? Look, this portion is already changed here. And again, if you look at here, this portion is already changed here. You have already changed it. There is nothing to change. If you change it to something else, actually you will create a match with something else, and that will be the same, okay? Okay, subnet into different sizes, okay? So you'll have different sizes. It will be efficient and it will be less wastage, okay? So you try doing this one. This is from class C, but obviously you may get from class B and class A as well, but always practice a few of them with class C so that it becomes much more easier for you.